Hello, my name is Trey King, and this is my presentation on Chat Apps War on Privacy. Instant messaging, or IM for short, applications have been increasing in popularity in recent years, and there's various reported vulnerabilities with these applications. So these two articles analyze security features and countermeasures. So Article 1 is a comparison of these chat apps. So after the NSA revelations from Edward Snowden, concerns for data security and privacy grew. Messaging applications are starting to tailor their features around consumer demand for confidentiality. And this article claims that 57% of all smartphone app users have either deleted an app or refused to install an app for security and privacy reasons. So this is a table comparing some of the security and privacy features for different messaging applications. I believe that encryption is the baseline security measure that any messaging app should have. Without this feature, no app should be considered secure because of the possible violation of confidentiality. And before reading this article, I was under the impression that the end-to-end part of end-to-end encryption was kind of just like a buzzword that tech companies threw out when advertising their products. I now realize that end-to-end encryption is the superior way to encrypt messages from user to user. This type of encryption is where messages are encrypted during transmission and no copy is stored unencrypted on the servers. Encryption in transit. This is a different type of encryption where messages are encrypted between the user and the service provider, but the message is then unencrypted once it reaches the server. As you can imagine, the service provider or a government agency could see the clear text messages as long as they have access to the server. I also value other security features presented in the article, such as a two-step verification protocol provided by Telegram or the open source policy adopted by both Signal and Telegram. A two-step verification requires both an SMS code and a password to log into the application, while open source allows for anyone to check the source code, protocol, and API. I think having more eyes on a piece of software is an effective way to spot vulnerabilities in the code, and the authors seem to agree with this. The article at this point determines that the most secure services based on the features are Signal, Telegram, Viber, and WhatsApp. The arguably least secure messaging service seems to be WeChat because of no end-to-end encryption and no transparency reports on China's government request for information, indicating that they allowed China's government to monitor their servers. Most messaging applications offer some way to store chat history as well as images and videos from the chat. Pictured is a table comparing all of the chat apps that the article found to be the most secure, along with Line and WeChat due to their popularity. The authors claim that Signal is the most secure option due to the app not allowing backups to a PC or cloud storage, and I agree with this. I think the most important thing to take away from this article is the factors it tells us to consider when choosing a messaging app. Being able to connect with others, the country or location of the user, the availability. Something also to consider is that these apps are already more secure than SMS because the cellular phone service provider does not own your messaging app data. The first article emphasized that end-to-end encryption is one of the most secure techniques an IM company can impose on their servers. But this article breaks down some key information that an adversary can extract even with end-to-end encryption in place, specifically their ability to detect if a certain user is either a member or an administrator of a specific group message. They can use IM traffic patterns to do this. The authors primarily use Telegram to test their attacks, and these attacks can be used on all major IM services and are not due to buggy software, and thus cannot be fixed through software updates. The adversary can use traffic patterns alone to find out if a user is part of an online chat group. For example, an oppressive government could use this attack to arrest users that are part of activist groups. To perform this attack, the authors created fake Telegram accounts and fake Telegram chats, but also needed a way to synthesize some more data. So they created synthesized or artificial data by modeling some IM communications. the researchers created two detectors based on traffic features in Telegram's API. The types of traffic features analyzed were IMDs, or inter-message delays, message sizes, and communication latency. Their first attack is an event-based detector. Figure 7 shows the basic workflow of the event-based detector, but the goal is to match instant messages events in target user traffic to those of the target channel. So this attack analyzes a sequence of traffic events. Image events appear as traffic bursts, whereas small scattered packets are protocol messages such as notifications, handshakes, updates, etc. The event-based detection algorithm works in three basic operations. It counts the number of event matches between the user flow and the channel flow of data. It then calculates the ratio of matched events by dividing a number of matched events to the total number of events in the target channel. Finally, it decides if the hypothesis is proven or denied by examining this ratio. Now we take a look at their second type of attack, which is a shape-based detector. Its goal is to link users by correlating their shape of network traffic. And shape in this case is a vector of packet lengths over time. This detection algorithm can also be broken up into three distinct operations. It converts extracted events into normalized traffic shapes. Then it correlates normalized traffic shapes using a specific statistical equation. And this value shows the similarity of the two traffic shapes. So one thing that I really appreciated about this experiment is that they performed their attacks on their own IM clients and no real-world clients. This means that they did not compromise the privacy of any real-world users. The researchers then compared the performance of the two attacks. So the graph compares some true positive rates to false positive rates. The true positive rate is the percentage of cases where the attack correctly matches the target to the channel in question. In both cases, we can learn from these graphs that longer traffic observations improve the accuracy of both detectors. It's apparent that the shape-based detector has a higher rate of true positives. However, when we compare the runtime of the two, the event-based detector is 2 orders of magnitude faster than the shape-based detector. The final section of the article discusses IM proxy, an obfuscation proxy designed for IM services. This technique counters some of the attacks mentioned in this article by changing the timing of events, by adding delays, and changing the sizing of events by adding excess traffic. They compared the IM proxy to both the event-based detector and against the deep learning classifier, and in both cases, the true positives were significantly reduced, thus indicating they were effective against the attacks. I think it was great that the authors offered an effective countermeasure to IM services for free, but I think not all IM services should use this technique. They must consider the cost considerations. For example, startup companies with IM applications may not be able to afford the extra computational resources required to implement IM proxy. IM companies must consider their target audience and weigh the benefits of an extra security measure. Their user base may not be so concerned about such an attack, and therefore, implementing it might be a waste of time and resources. Companies must ask themselves this question: are you security focused? I do think security focused applications should consider incorporating this into their system, especially if their user base happens to be in a country where their government restricts free speech and has a history of monitoring users of chat apps. This discussion comes back to the points set up in the previous article. Users should weigh privacy against other factors such as convenience, UI interface, and functionality. They should also weigh in the cost of being monitored and discovered based on their message topics. Even with end-to-end encryption, adversaries can still find out valuable information about users. I do think that an updated comparison of security in chat apps is required after companies implement IM proxy into their systems.